we know how to define a point in a space, and let's see how can we find the distance between those points. And it's very parallel to what you did in calculus 1. So if you have 2 points on a plane, you know how to find the distance between those 2 planes, right? What you are doing, you are taking the difference and then you are taking the square of these differences and you are putting them inside the square root. And exactly the same thing for the three-dimensional space. You need to take the differences, you need to take the square and then put them into the square root to be able to find the distance between the point P1 and P2. Okay, let's look at it on example. So the distance for P and Q. P is a point, you know, in three-dimensional space. It will be just 1 point and you know how to plot this one. You will go 10 units on the x-axis, minus 2 units along the parallel to the y-axis, minus 7 units parallel to the z-axis. So please try to plot these points on the xyz plane as an example or as an application for you. Check that out. And now we are trying to find the distance between those 2 points. And here is the distance formula. What does it say? It says take the difference of the x values, y values, z values, take the squares of them, put it inside the square root. Exactly, this is what we do. 0 minus 10 squared, 8 minus 2 squared, minus 2 minus 7 squared. We are taking the square root. It is going to be 125, which is 225. Square root of 225 will be 15. So this is the distance between the point P and Q. Okay. So from this distance formula, we can come up with more interesting things, like an equation of a sphere. So in this example, it's asking us find an equation of a sphere with radius r and center HKL. HKL is just a point. Any point it can be. Okay. So this is the sphere, right? This is our center and we are looking for an equation of a sphere with radius r. And let's say if this is the center and if this is the radius r, let's say this point is x, y, z. And you know how to define a distance between P and C. And you know the result of this distance, which will be r. So let's use this distance formula and let's make this distance formula equal to the r, because the distance between P and C is r according to the sphere. Whatever this point is, any point you take, you know that the sphere has a radius r. So by definition, a sphere is the set of all points whose distance from C is r. That's why we are taking any point x, y, z. We are using the distance formula. This PC should be r, and PC square is gonna be the r square because this is the square root. So if you take the square of this one of each side, this is gonna be the r square. So it will be x minus h square, y minus k square, z minus l square is r square. And exactly this is the equation of a sphere with radius r, okay, and center HKL. And by using this one, you can write an equation of a sphere with any center and any radius. For example, this one. Show that this equation represents a sphere and find its center and radius. So we know that the general form of the sphere is like that. So we need some squares. We need to complete the square for x term, for y term, and for z term, so that I can have this form and I can find the center of the sphere or the radius of a sphere. And to be able to do that, let's complete the square of the x term, which is x square plus 8x. So x square plus 8x, if I add 16 here, this will be exactly the x plus 4 square. That's why I am adding 16 here. You know that what you are adding? You are adding b over 2a square here to make this x term turn into the complete square. Okay? So b is 8. 2a is 2 times 1, 2. 8 over 2, 4. 4 square is 16. So this is gonna be x plus 4 square. And for y, what do we have? Y square minus 6y. So if I add b over 2a square, which is 6 over 2, which is 3, 3 square is 9. That's why I'm adding 9 here. And for z, we have what? Z square plus 2z. So b is 2, 2a is 2, 2 over 2, 1, 1 square is 1. I'm adding 1 here. Since I add those, I don't want to change the equation. That's why I need to subtract the same values from here. Plus 17 is already there. I am also putting it there. And if you calculate these constants, it will be minus 9. So let's put this one onto the right hand side. It will be 9. So this term is exactly x plus 4 square. This term is y minus 3 square. This term is z plus 1 square equals 9. And as you can see, this is exactly the form of the equation of a sphere with center what? HKL. HKL is minus 4, 3, minus 1. And the radius r square is 9, which is r is 3. So if you compare this one equation with the standard form, you can see that the center is minus 4, 3, minus 1, and the radius is 3. Okay? This is how you can find from this general form of the equation to the sphere. And I will assure you that I will ask one question in your midterm in that way. Okay? Please make sure that you understand it.